Alright folks, welcome back. Today we're going to solve another question from the first chapter of the Johnston textbook, question 16, and we have two wooden planks, each of them 1/2 inch thick and 9 inches wide, and they're joined by the dry mortise joint, as we can see. So we're talking about this joint in here, which is our mortise joint, and we know that the two would use shears off along its grain when the average shearing stress reaches 1.2 ksi, and in this one we need to determine the magnitude of P of the axial load that will cause the joint to fail. So we can see at the end of this we're gonna have some shear stress on each of these, and we know that shearing stress would be 1.2 ksi. So since we are in equilibrium, we have to figure out the value of the P here. So as I mentioned, we're gonna be dealing with these surfaces here, which from the question we know that if we show it in here, so we'll have a surface like this, which we know this distance is what we have in here, which is 5/8 inches, and from the question we know the thickness is 1.1/2 inches. So we have that in the question, and we know it's 9-inch width, which is what we have in the figure 2. So this is the surface that undergoes that shear stress, which we can show it here. So we have this shearing stress on this surface, and if we want to find the force, since our P on the other side is force, we cannot go directly with this shearing stress. We have to find the force firstly. So we have force over the area. So the area is pretty easy. We have a rectangle area, and we know each of the sides. So one of the sides is 5/8 and the other one is 1/2. We have to figure out the F, and this will be equal to 1.2 ksi. So when we have the ksi unit for the shearing stress, we know our area has to be in inches squared, and we have our force in kips. So it's pretty easy here to find our force, which will be 1.2 times 5/8 times 1/2, and if we calculate this, we're gonna get 0.375 kips. That's gonna be our force in here. So let's get back to our figure in here. Now that we know the force in each surface is this value, 0.375 kips, so we have this force in each of these surfaces. We can show it with F, here 2, here 2, and here 2, and if we count them, we'll see that we have 6 in total. And if we want to do our equilibrium equation, sum of all forces in x direction is equal to 0. We can consider our x and y here. Obviously everything is in x direction, so no need for y. And if we do that, basically our equilibrium equation, we have P to the right, so positive minus 6 of those F's is equal to 0. And if that's the case, our P would be simply 6F, which will be 6 times 0.375 kips, and if we calculate that, we're gonna get 2.25 kips, which would be the final answer for this question. So in the second part of the question, again, we used our equilibrium equation since we are in equilibrium, so that way we have 6 forces of F to the left, and we have the force P, and we are looking at the free body diagram of this part of the figure. So that's pretty much all the forces that we have applying at the member on the right side of the figure. So yeah, that wraps it up for today's video. If you guys have any questions, feel free to drop it in the comment section. I'll be happy to answer those. Make sure to subscribe to the channel, like and comment. It's going to help me to reach out to more students. I have another channel that I specifically solve the engineering mechanics question and statics. I'm going to put the link in the description below. If you need some help with that course, feel free to check it out. It's going to be very useful, and you guys take care. I'll see you in the next video. Have a good one.